Okay. So welcome to chapter 11. This is the second part of our class. So that means this is going to be just material for the final. And today is the first time we're going to try to think about markets, right? So, econ is not only about consumer decision making, right? It's also about markets and how firms behave and consumers behave together. So, one of the key advances of economic thinking has been, the idea of Marshalls, of the scissors, right? That you cannot cut, a piece of paper just using one half of a scissor, right? You need the two sides, and these two sides essentially, are supply and demand. So consumer behavior controls, of course, demand, and the firm behavior controls supply. Now we want to put them together. And the first time we're going to do it is today by using essentially the tools of competitive markets thinking and partial equilibrium. So partial equilibrium is going to be a way to say that instead of studying a very complicated multi-market situation, we're going to try to study a very special case of a market where we're going to face essentially one market. So right now, right, of course, in our theory, we're going to start a little bit more general and start thinking about an exchange situation and thinking about competitive equilibrium. But at the end of this chapter, we're going to be focusing on essentially what you did in undergrad, which is an exercise, of course, more mathematical, but supply and demand. So this famous cross, right, analysis using the supply and demand curves. The level is going to be higher, but that's essentially it. Now, as we progress through the second part of the class, it's going to get harder because we're going to study what's called general equilibrium. And general equilibrium analysis uses multi-markets. So multi-markets are interconnected, and whatever happens in one market is going to affect other markets, right? So that's going to be much more complex. So let's start with the easy one. So competitive equilibrium. So the first time we consider a market, what is a market? A market is going to be a collection of consumers, capital I of them, and firms, capital J of them. There's going to be L greater than equal than 1 goods. Right now, we're seeing the very general framework. Consumers' preferences are going to be defined over commodity bundles, right? And as you notice here, notation is the key for this chapter. We're going to use almost what's called Einstein notation. So the idea is that when you have a vector, is in fact an array that can be very complex. If you remove some subindex, then this is going to capture essentially a vector, right? So for instance, if you have x sub I, this is going to be the vector of goods for consumer I, right? And if I remove the I from that, is going to be the array of all the consumptions from all the individuals and all goods, right? I'm going to explain more as we go, but right now the first item of interest is going to be the consumption bundle Xi, which is essentially indexed now by consumers because we have many of them. Otherwise, it's the same as the chapter 3 Mascolet, right? The consumer choice chapter. And then, of course, preferences are captured by a utility function. Now, because we have I consumers, utilities are also indexed by the sub I subscript. Now, importantly, in this idea of markets, what is the big change that we're going to make? So far, both in the consumer chapter and in the theory of the firm chapter, firms and consumers took as given prices. So prices were a part of the problem, right? You were given prices and income in the consumer chapter, and then given prices and income, you make a decision. You maximize your utility subject to the budget constraint, right? The same in the theory of the firm. You were given a price vector of inputs and outputs, so you maximize profits or you minimize cost. Understood, right? So now here in the theory of the market, the first time, prices are going to be defined endogenously, okay? So prices are going to be defined through exchange, okay? And essentially, since we don't have prices anymore, there is going to be a different primitive for our theory that is going to call endowment. So endowment is going to be essentially the initial existence or inventories, if you want, of the goods in the market. and they're going to be captured by this symbol omega. And again, how many of them there's going to be? It's going to be L of them, okay? Because it's the same goods and in a market. Just typo here. And the restriction is that the quantities of endowments in the market are going to be positive, weakly positive. Now, these endowments may be used by firms to transform them into other goods, so they can be used as inputs. And also, they can also be consumed directly by consumers, of course. For instance, think of apples, right? So the fruit, apples. So you have apples, and then some firms may use it to make apple juice, right? Also, an alternative use of this apple is that the consumer just directly eats the apple, right? So that's essentially two possible uses of an endowment good. Now, each firm here is going to have available to it the production possibilities summarized by the production set. So remember from the videos, the production set is this mathematical description of basically the technology of a firm that transforms inputs into outputs, right? The version that you learn possibly in undergrad or master is the production function, right? So what is a production function? So can someone of you remind me what is a production function? Else I'm going to ask, as you know.
A function that maps inputs into quantities of output of a given product, final good.
Exactly. So Martin mentioned two important things. So a production function, you know, mathematically is a mapping, right, from a vector of inputs to a scalar value of one output, right? So the production function is essentially this special case of the production set where you have just one output, right, and possibly many inputs. And one of the classical production functions everyone studies, especially in macro, right, the famous Solow model. Who remembers what are the inputs? So capital and labor, right? Capital and labor, and then you produce, you know, some mixed composite good. Okay. Now, in real life, are firms one output only? Not really, right? So think, for instance, of a textile factory, right? That produces many types of textiles. You know, they can produce sweaters, pants, you know, socks. That's a multi-output firm. Okay. So what are the inputs there? Wool, color, you know, other things, you know, all of the labor, of course, capital and machine. So all of that is the vector of inputs. They can be producing multiple outputs. So the production set is essentially capturing this multi-output technology, okay? So all of this is from the firms chapter. And now, importantly, you know, mathematically, the production set is very simple because it's just a subset of the Euclidean space. And remember that the production set is a very convenient mathematical object because any vector that belongs to the capital Y set or the production set is a feasible set. So it's a combination of inputs and outputs that the firm can actually produce. If such another vector that includes input and output, a production plan, but does not belong to the production set, is unfeasible. So it cannot be produced by the given firm. So the production set is the analogous of the preference of the consumer, right? They contain all the information needed for the firm to make their decisions. So what are the firms doing with their production set? They are maximizing profits in this setup, okay? Now, an element, as I say, right? So as the analogous of the commodity bundle bought or chosen by the consumers, for the firms is the production plan, which is denoted by lowercase y and subindexed by the firm. So I have capital J of them. So each firm is indexed by a subscript J. And then the production plan is again a vector of L goods, okay? And it is indexed by the firm. So the net amount of the good of the good of the economy, of any good L, so good L in the economy, in fact, is the summation of the endowment of the good plus all the production and the use of inputs in this economy. To note, why, as you remember from the videos of the production firm, of the theory of the firm, when it's negative, it's a negative value, is the use of the good as an input, right? So that disappears from the economy, is subtracted from the economy. Hence, it has a negative sign. If it is a positive sign, is an output, right? as an output, this is going to add the existence of this good to the economy. So the total existence of these goods in the economy are going to be the endowment, the initial value, minus the uses as an input, plus the production as an output, okay? So that's essentially the total existence of the good in the economy. And of course, the total endowment, as I mentioned with this Einstein notation, is going to be this omega L, where the subscript I has disappeared, which essentially means that this is the summation over all individuals, okay? So what is the total endowment of apples in the economy? Well, I do a census of who has apples. I count how many apples do you have. I add the existence of apples, and then I obtain this value. Now, the new object of interest, so remember that before in the consumer chapter, we were interested in the consumption bundle, right? In the theory of the firm, we were interested in the production plan. In this second part of the class, we're interested in an economic allocation, right? So which is essentially a big array, a matrix, in fact, of allocations where each column here, right? So each column of this big array is essentially a vector of size L, right? And the index here is indexing the consumer. So this is consumer one vector of commodity bundle, which has L goods. This is consumer 2, ... consumer capital I. So if you have, for instance, 10 consumers, this would be 10 vectors, column vectors stacked together, each of them of size L, okay? And then next to it, we stack the production plans. Production plans from Y1 to Y capital J, okay? So that's essentially it. What is the size of this thing? So the columns of this thing are I plus J, right? Because it's capital I consumers plus capital J firms, I plus J. Now, what are the rows of this big matrix are L goods, right? Everyone understands? So this is what we call essentially an economic allocation. Important thing in Mas-Colell, right? So here he's super economical about notation, right? So he never explains dimensions, right? So a good sanity check when reading my notes or Mas-Colell is doing a mental note of what is the size of the object here. So this is a matrix again, which how many columns? Capital I plus J, so the total number of consumers plus the total number of firms, and whether the rows are capital L, the total number of goods. Okay, this is a good sanity check. And what is an economic allocation? Is essentially the summary of all consumption of all consumers and all production, including inputs and outputs, right, from firms. And this is essentially what is called an economic allocation. Okay, everyone understands the definition? Okay, very simple. We're just stacking together things we know. Now, important definition. So the allocations that we're going to be interested in as economists are going to be called feasible allocations, and they're going to be feasible if they satisfy the following inequality. The inequality is the following, is that for every good L, right? So for every good L, the following inequality holds. So the summation of all consumption bundles, XL, I, over the consumers, right? So the total consumption of all the market is less than equal than the total existence, right, of physical amount of good L in the economy, which I already told you that is equal to the omega L, which is the total endowment, right, plus the net existence of goods, subtracting the minus signs of the Y, which is the use as an input, and adding up the creation of the good, okay? So if whatever is consumed is less than or equal to whatever exists in the economy, is a feasible allocation, okay? So important thing here, as you realize, so this is not an individual budget constraint. This is a market-wide constraint. Do you understand? So this is essentially saying, right, that I can fit everyone here, you know, in this class with the existence of apples, right, in Western. So that's essentially what I'm saying. So I'm fixing a market, right? In this market, there is an existence of a good, say apples, and then I'm ensuring that I can feed everyone with these apples, right? And remember, this is not about needs, right? This is about what people want. So X is just capturing, choices. So this is about what people choose, right? Not what people need. So now, whatever people want to choose has to be feasible, has to be within the realm of the physical existence of goods, right? So right now, firstly, if every one of you now wants, wants to have a kilo of gold, right, delivered to you by tomorrow, well, probably is not likely, right? So if everyone in the world gets that, so there is not enough gold for everyone, right? There has to be existence of, there has to be a ceiling of whatever you can buy. Now, important definition now. So the allocation XY and the price vector P. So this is a pair, right? So an economic allocation X semicolon Y and a price, which is a vector of size L, constitutes a competitive. First time we use this marvelous concept, right? Competitive over ration equilibrium if the following conditions are satisfied. So the first condition that has to be satisfied is that the Y part of the economic allocation, so the production plans, are profit maximizing production plans, okay? So important thing is that whatever is an economic allocation here, that is part of a competitive or valuation equilibrium, has to be the result of firms profit maximizing, given, of course, a price given here, and given their production possibilities captured by the production set capital Y. So given this, they maximize. Condition 2, utility maximization. So all the excess in the economic allocation has to be the result of utility maximization. This is a big change here, so I want you to pay a lot of attention. So what was the main thing that we did in chapter 3? So we gave consumers price and income, and then they maximize their utility, right? Here, the budget is going to be endogenized, right? Because prices, remember that prices are going to be formed here endogenously, right? So essentially, your budget has to be endogenous in the following way. Instead of giving you an income, right, as in a fictitious experiment, you're going to be given here endowments, right? Physical amounts of goods. And then with this physical amount of goods, you're going to be able to sell them, right? For a price, of course. And this is the multiplication of price times endowment given to you. With this notation of the inner product, remember that omega I denotes a vector of whatever you own in the L goods. And then you multiply it by the price vector of size L, right, to obtain the whatever you gain from selling this. And then there is an additional term here that has a new component, which is very cool, which is this theta ij. So theta ij is a number between 0 and 1 and denotes a share of a firm J owned by I, such that if, of course, I add over individuals, then everything here is owned privately. So all firms in this market are owned by the consumers, okay? So all shares are in hands of the capital I consumers. So what are the profits of these firms? So clearly it's prices times the production plan. Remember, the production plan is already a profit maximizing production plan. So prices times Y is already the profits. So multiplied by the share gives you your share on the profits of each firm, okay? So now, as you can see, all this term here in the right-hand side is not longer an exogenous income level, but rather an endogenous income, right? That is the result of selling your endowments and your shares of the profits that you privately own, okay? So each consumer here has preferences, has an endowment of goods, and then has shares over the firms, okay? Now, so as you can see, given this endogenous income, now they can essentially buy whatever goods they want, given the prices. And then finally, the condition that is called market clearing. So now market clearing says that the summation of all physical goods is equal to the total existence of the goods plus whatever is produced and whatever is used as an input. Okay. So now here we're using an equality. Before this is, I'm using Mascolel. So this is a little bit of an internal inconsistency in Mascolel. So essentially market clearing, is requiring that everything is exhausted. Now, in general, we can use an inequality. And of course, the key driving force, whether we use an inequality or equality, is going to be local non-association, right? As long as we have local non-association in the utilities, right? Then we're fine. Then we're going to be able to use this equality here. Now, but this is the first time we introduce the concept of a market. Now, I want to make some comments here because in order for you to really understand what's going on. So the first things here that we're checking is essentially three conditions that we are verifying: the economic allocation and the price satisfied. So in this sense, this is endogenizing the price, right? So as you can realize, essentially, I can reframe these three conditions as a system of essentially nonlinear equations that are going to be defining two variables. First, the economic allocation, so whatever people consume and whatever firms produce, and a price vector. So essentially, these three conditions, are a way to describe a system of nonlinear equations that are going to have as a solution whatever people consume X, whatever firms produce Y, and the price that markets clear all of these. So prices have the role, right, together with economic allocation, of solving this system of equations. Now, right now they don't look as a system of equations. So we're going to do some more work in order to make them look like that. But essentially, that's what's happening, right? So mathematically, is a system of nonlinear equations, right, that produces as a solution an economic allocation and a price. Okay. Now, economically, this is putting together the behavior of consumers with the behavior of firms, and then essentially is putting them together in a market. The market here requires that everything aggregates such that whatever people consume is equal to whatever exists in the economy. So it's a closed market. It also is a private ownership market where every firm is owned completely by consumers, right? And essentially, consumers are not given any initial income, right? Their income comes from the existence of endowments, which is physical amounts of goods that they can sell. And then essentially at that moment, they are gonna somehow coordinate, and I'm gonna highlight this. They somehow, firms and consumers, somehow coordinate such that there is a price and an economic allocation and a production plan that solves all these conditions. Now, so this theory, right, is not a theory how prices are formed, right? It's just an abstraction of a situation where consumers and firms behave as they are behaving in our previous chapters. So firms try to profit maximize, consumers try to utility maximize, and now they are put together such that they generate in equilibrium. First time we introduce this notion, a price that allows them to coordinate, right? So the price is this magical information device that allows everyone to maximize or search for their own selfish interests while achieving essentially a social coordination problem, right? So they are solving an issue of a social coordination issue by means of a price. So I'm gonna be talking a little bit more about what follows, but right now you get the definition, right? So mathematically, and Walrasian equilibrium is essentially this economic allocation and a price vector such that satisfies these three conditions, right? Profit maximization, preference maximization, and market clearing. Okay. Now, so this is the kind of high-level version of supply and demand, right? So when the supply and demand cross, there is a point. That point gives you a quantity and a price, right? This is what we're doing, but now high-dimensional, right? More complex and with heterogeneity, right? We allow many consumers, many firms, of course, prices of many goods, right? And then essentially we're also endogenizing property and we're endogenizing income, right? So it's a way more general version than the supply and demand in your typical undergrad class, okay? Now, this is not the first time we're going to look at a market, so we're just going to keep going and do some analysis. But remember, you know, when we're going to study this, what is the big objective, right? So the big objective, if you go to the Mas-Colell preamble to this chapter of competitive equilibrium, you know, Mas-Colell, Winston Green, they have a really nice preamble, you know, making very clear, you know, the level of ambition of this theory of markets. And essentially what they wanted to do is very ambitious because they wanted to be able to predict prices, right? Predict what people are going to consume and what firms are going to produce from knowledge of preferences, knowledge of production or technologies. And of course, assuming or knowing that the structure of property is, for instance, private. So given these three things, essentially we're aiming to predict what prices are going to be and what consumptions and production plans are going to be. And we're going to actually trying to predict this in every possible market, right? So if economists were successful at it, essentially you could predict, you know, what would be the prices of tomatoes, you know, what would be the prices of transportation, what would be the prices of course, the wages of different professions. And you will be able to do it in a way, you know, that is very precise. And also, given those predictions of prices, you will be able to know exactly what people consume and what firms are actually doing. So economists have come a long way since we first started this with, of course, one of the first individuals that tried to do this, Leon Walras. Leon Walras or Walras, whatever pronunciation you like, he was a French trains engineer, and he, you know, proposed for the first time, you know, inspired by previous work by French economists, what was a system of nonlinear equations describing an economy where there was both sides, you know, both the supply side and the demand side. And by interaction, you know, through what he defined as a market, a price arise that allowed them to coordinate and to allow, you know, what is called now an equilibrium. So Leon Walras, you know, had this great idea that, you know, every market is interconnected and we could write and describe behavior of consumers and firms by mathematical equations. And in fact, by optimizing behavior, and then using this idea, we could predict what people are going to do. Now, you know, this is, of course, an amazing idea. And of course, we now modernly are still debating whether the parts of this Lego, right, are actually the correct parts. For instance, you know, you may have issues with people actually maximizing utilities, right? Or we discuss the issues with rationality. Or for instance, the fact that people may be assumed to be fully attentive, right? That they know every price in the market. And hence, you know, again, challenging the utility maximization framework. You may also have challenges to the idea that firms profit maximize, you know. There is not enough evidence that a lot of firms actually do that mechanically. Maybe they're doing other things, right? Maximizing other goals. So taken all together, you know, the Walrasian equilibrium, right now, I want you to take it as a very abstract construct that allows us to think systematically of how consumers and firms get together. But right now, I don't want you to think it as a true description of how markets behave, right? It's going to be more of a intellectual exercise and a modeling tool and a modeling technique that allows us to put together, you know, consumers and firms. Now, important thing for something that is abstract, it doesn't mean it's not useful, right? So one important thing that economists have learned is that we don't longer believe that we are just scientists or just people that describe reality, but we can also be engineers. And one important thing that's going to arise from the study of markets is that actually economists can create markets, okay? So we can create marketplaces and we can actually create conditions under which our models actually predict what we want to do. So one important new branch of economics is what's called market design, right? The design of markets, right? And this is, the first entry in this realm. So this is just to say that really the purpose of this, general equilibrium and competitive markets has grown a lot since the time of Mascolel. So we no longer claim that we're going to describe and be able to predict whatever to do. That's very complex. We're still very green as a science to do that. But it turned out, right, that the static market is very useful because sometimes economists can create synthetic markets, right, where our assumptions actually can be by design satisfied. And then, it turns out that we can actually do something useful with our models, right? So it's a little bit more trying to be engineers rather than scientists, right? So right now, given this preamble, we're going to try to study how these markets work, right? And if we can learn something, from these three assumptions, right? That consumers are assumed to preference maximize or utility maximize, that firms are assumed to profit maximize, and that markets should clear. With these three assumptions, the objective is to try to discover what are the possible predictions that we can make about this market, right? So remember what was the objective of the consumer chapter. It was from the existence of a budget that was observed, right? And from the knowledge of a utility function, we wanted to predict what the consumer was going to do, right? And then, of course, we were able to go really deep into that question, right? And be able to know exactly what the consumers were doing, what are the empirical implications of the consumer demand that is rational, and so on. The same thing for firms. If firms are profit maximizing, what are going to be the empirical implications? What can we predict about their behavior? Now, we have one more thing to predict. We no longer predict only the consumption of the consumers or the production plans of the firms. Now we want to predict the two things that I just said, plus the prices that are going to allow them to coordinate, right? So the key object, the new additional object that we're going to introduce as part of the prediction problem here are prices, okay? So we want to predict prices. So in order to do that, we have to realize some caveats. The first thing is that if we want to predict prices, we will never be able to predict using this model level prices. We will only be able to predict ratios of prices. That is to say, for instance, that using this type of neoclassical market models, we will never be able to predict that the price of apples will be 10. We'll only be able to predict that the ratio of prices of apples to oranges is going to be 1/2. So oranges are going to be more expensive, hypothetically. So mathematically, this means that if the allocation X and Y, again, Mascolel notation alert, now Mascolel collapsed this big matrix into this very economic notation, parentheses, X, what is X is a matrix, semicolon Y, another matrix, stacked together, they're the bigger matrix of capital I plus J columns with L rows. And now this is written in this very Einstein notation, X, Y, right? And then prices, which is of size L, they constitute a competitive equilibrium. Then this different allocation with sharing X and Y, but with a different price, alpha of the original price, for any alpha positive is also a competitive equilibrium, okay? So what it means is essentially that if I take a price and scale up all prices by alpha, then, this is still the same competitive equilibrium. So if you take and double every price in the economy, right, this is not going to affect the problem of the consumers. Why? Because of homogeneity of degree 0 of the consumer problem, right? So notice, if you go back here, that crucially, income is endogenous. So if I double prices, I'm doubling the income of this endogenous income guy. Do you understand? Because I'm doubling the prices, I'm doubling the amount they get by selling the endowments, and I'm doubling nominally the profits they are getting, okay? The share of profits. So income is doubling by, and then so are prices. So by the homogeneity of degree 0, the real budget faced by this consumer is not changed, right? So check, consumers are still doing the same as before. Now, if I go now to the problem of the firm, the change in prices does not change the technological possibilities, right? So capital Y is the same, the only thing that the alpha scaling or the doubling the prices is doing is doubling nominally the profits, right? But it's not changing the actual production plan, okay? So it's not changing at all. So it's just changing nominally the objective value, but it's going to be essentially the same feasible thing, because doubling the prices does not allow you to have more products, right? Only makes them, you know, twice this more expensive, okay? So together, of course, if you go to market clearing, prices do not enter, right? So they don't have anything to do. So we have verified, right, that this claim is true. This scaling of the prices should be essentially neutral, okay? And this is what is called the neoclassical neutrality of money, right? So this is a very historical point, you know, that essentially the first models as created by Leon Walras, you know, essentially they imply this property that if you scale everything up by twice, you know, nothing should change, okay? Now, again, this is a consequence of the assumptions we're making, right? Crucially, the assumption of attention to prices. So consumers are fully attentive, right? So they know exactly the prices they're having. Of course, the budget constraint of these guys are essentially, you know, just doubling in income. So there is no channel in which you can, you know, gain more money fictitiously. So this is a real economy. So all prices, of course, the only prices that are meaningful are relative prices, okay? And that's a key important feature of this competitive valuation equilibrium, is that the only thing that we care is about real prices, which are essentially ratios of prices. So we just care about relative terms of exchange as captured by the price. And then, of course, the scale of the price as given by the alpha here is irrelevant for the economy, right? It just gives you the units in which you're measuring, you know, the income that you get. Any questions here? But that's the first thing we're going to learn, is that essentially, you know, this model predicts that money is neutral, right? So if you basically double every price, double every price in the economy, then things remain the same, okay? We have just changed the units. Now, the other thing we want to know is lemma 8, if the allocation x and y and the price vector p satisfies the market clearing conditions. So remember, market clearing requires that whatever you consume is equal to whatever exists in the economy, endowments plus production. And essentially, this happens for all goods L different from K, where K is a fixed good. And if the consumer budget constraint is such that you have this multiplication of price times Xi, Xi is denoted in the commodity bundle, so vector of size L of consumer I is equal to the endogenous budget constraint. So not with the less than equal, but actually equal. Then the market for good K also clears. So what this means is, imagine you have 10 markets and you verify that 9 markets are basically satisfying market clearing. Then it has to be that the last 10th market also clears, okay? And essentially this happens, again, due to, is a consequence of the consumer problem. We remember these two properties, homogeneity to degree 0 and Walras law, right? So as you can see, the budget constraint, if we assume this is calling with equality, it essentially we're assuming local non-association, right? Then what this is saying, right, is that if 9 markets already are satisfying the market clearing, then so will the last one. And, you know, essentially this is a consequence of homogeneity degree 0 and, you know, Walras law and of the previous claim. So money is neutral, right? So everything is measured in relative terms. If there is essentially one market that is redundant, right? It's kind of closing the accountability here, right? So it's essentially closing the fact that you have to satisfy your budget constraint. So there is always one market that you don't need to analyze. So that's very important for us as students of these markets, because this simplifies our problem greatly. So with these two lemmas, essentially what I told you is how to simplify your problem sets, okay? So this is the practical thing. The first thing is that I told you, look, find the valuation equilibrium of this economy. So this is a classical question in the core exam, right? So I give you an economy. So, one of the micro professors gets super creative, right? In winter, of course, when you get bored, right? And then you create these very weird preference relations, right? With very weird stuff. Locant association fails, convexity fails, all the nice things fails. You create two such consumers. And then, of course, you have now three markets, right? To be fun. And then I have, imagine three firms as well. And then I have three goods, a classical 3x3x3 model. Now, you as smart, attentive students will quickly realize that this is fake three goods. It's not really three markets. It's only two, right? First of all, you don't have to find the prices of good one, good two, and good three. You only have to find the relative prices. So for instance, you can choose to normalize the price of the first good one, and then you can only find the ratios of price of good two with respect to good one and good three with respect to good one. So you have reduced the unknowns instead of 3 to 2. The second thing is if you're checking market clearing to see if you have found your rational equilibrium, you don't need to check the three markets conditions. You only need to check two of them. And then you know already that if this equality is holding, this condition is holding, that the budget constraint is holding with equality, then you know the third market is fine. Now, important thing about this chapter, when you read it, when you study it, and when you prepare for the core exam, is being super aware about the assumptions. So here, the assumption of lemma 8, as you can see, is that if the consumer budget constraints are such that they hold with equality. So of course, Locant association is a sufficient condition for this assumption, right? So if you assume utilities are Locant associated, then this holds. Now, is Locant association the only thing that will make this hold? Not necessarily, right? But this lemma is given with respect to this condition. So if you verify that condition, you can use lemma 8 and save some time by not checking the third market, right? If the micro professor designing your core exam is bored enough such that this person removed this assumption, then you cannot use anymore lemma 8 and you have to do it by hand. Are micro professors evil enough to do that? For sure. Have they done it? Yes. Will they do it again? Yes, again. So you are warned, okay? You're warned. This is one of the classical, trick questions. Not really a trick question. I guess the good faith interpretation would be, this is to actually see if you really understand, right? I don't like that kind of questions, but my job is also prepare you for this kind of exams. And, I have seen the exams of the previous years. This is a classical one, kind of give you something that almost looks like the assumption, but then actually the assumption fails. So the whole game, for this is not hard, for you is essentially, when you read these lemmas, really pay attention to the assumptions. And then when you're given a problem set, all these lemmas are kind of, tricks or shortcuts to be able to simplify these problem sets. However, it is your job to verify whether the assumptions that guarantee that you can use the result actually hold, right? If they don't hold, you have to be aware of it and then be able to, change your course of action, okay? So I'm already telling you how to study this chapter. It's essentially, learning all these tricks to simplify the computation or finding, the well-rational equilibrium, and then actually verifying whether this holds or not. If the assumptions do not hold, then you have to do things by hand. There's a little bit more work, okay? But that's essentially the trick in this second part. So this is one key example, but the usual trick, and this is essentially you will use in your professional life. If you become a macroeconomist and you go to work in the Bank of Canada, you will use this forever, right? So macroeconomists are not messing up with this. This simplifies the world a lot, right? So essentially, prices are relative, and then you can just check one less market than usual. Okay, so this was very abstract, not very helpful. We're going to repeat, and then we're going to try to make it more helpful. So I'm aware that this was a little bit too abstract. Now, the important thing is that now we're going to try to land the plane, okay? Now things are going to get cooler. And why is that? Because essentially our objective now is to revisit a classic of econ. So every one of you did demand and supply, right? Okay, great. you did it graphically. Some of you are more advanced and you did it more, analytically. Now we're gonna do it fully analytically. So the black belt version of the cross, right? The mana supply, very fun. And this is actually one thing people use a lot. So one thing you're gonna use in all, if you become a consultant, a macroeconomist, you go to the private sector, is this partial equilibrium analysis, right? And this is one of the most useful tools ever. So we're gonna study for simplification. So finally, right, some simplification. Instead of many goods, we're just gonna study 2 goods. Very nice, right? The first good, good L is, and of course with the consumption xi of consumer I, but now this is just a scalar, so it's no longer a vector because there is only one good. And then this is basically you can think of corn, right? So this is development lingo, right? So the good you eat, the development guys call it corn, okay? For whatever it's worth. So you can think of it as corn. And then, a numeraire. So the numeraire is essentially you can think of it as money, right? And, fittingly, we use M, right? So X is corn, M is money. And then each consumer has a quasi-linear utility that gives you some phi, which is a nonlinear function, capturing, the marginal utility of eating corn. And then, of course, you can also use just not eat corn and have the money, and this will enter your utility additively, right? And then, of course, this utility is assumed to be measured in money, okay? So it's a cardinal utility, okay? So the units of these things are money, and then essentially are money you don't spend in corn, so they enter directly in your utility, or then you consume corn, and then this goes through the phi function, okay? Importantly, phi is indexed by sub I, so it means there is different marginal utilities for each consumer. So as opposed to your undergrad class, right? So here we allow each consumer to have their own marginal utility, right? So very fancy. And then each consumer can consume whatever level of corn they want. So this is the X sub I. And then, of course, they're going to be given different levels of money. So they have different M sub I as well, right? So everything is indexed by I. And this model is going to be, even if simple, general enough to allow any number of consumers, right? So we can have 100 consumers, 1,000 consumers. Everything is going to work. Now, the consumption set is going to be, of course, so this, we can make it very complex in this case, right? But essentially here, so we are not going to have L goods right now. So I just want to make it 2 goods. Well, you're going to see essentially that whatever we do here, we can make it, of course, high dimensional. But right now it's super simple. So the consumption set is the numeraire here is not restricted to be positive. Importantly, the numeraire, because it's taught as money, and to deal with some mathematical issues of corner solutions, is going to be to allow to be negative. So when it's negative, essentially it means that you don't have that money. You owe this money to someone, right? But this is more a mathematical convenience to just have interior solutions. And then the function phi, as I mentioned, is consumer dependent. So each consumer has its own phi, is bounded above and twice differentiable. So this is just a technical condition. It doesn't have really anything deep to it, but it's gonna allow us to close our model technically, right? So allow it to have an equilibrium. So the first thing, as I mentioned, right, is bounded above and twice differentiable, such that the first derivative here is positive and the second derivative is negative. So this is the marginal utility of corn. So it means the more corn you consume, you're happier, right? But as this corn consumption increases, the increase of your happiness gets smaller as this increases. So the marginal utility is decreasing. So the second derivative is negative. The first one just tells you that your utility is monotone on the corn. And this only happens for positive quantities. And we normalize without loss of generality that if you consume 0 corn, your utility of corn is 0, right? So this allows us to have this money interpretation of the utility, okay? The numeraire M sub I is a composite, nice word in Econ. Composite good is a magical word. Is a modeling device, defined by one great economist, Lancaster, right? and Variant and others, that essentially says, because we have this linear budget constraint, right, we can just stack everything together that is not corn into one single good, right? And then assuming, your utility such that it's separable, such that, whatever is left was here, there was a big utility. I don't know how it works. And then, essentially you can break your utility into two additive terms. And then everything in the budget, because it's just additive, you put it together into one single composite good. So this composite good, sometimes it just can be thought as money, right? Pocket money. Or sometimes can be thought as, this abstract object capturing, the basket of other goods, okay? The key idea is that XI is small relatively to the whole expenditure, and thus well effects are close to null. So a lot to take here. So this is a classical Mascolet writing, right? And following Mascolet, but I'm giving you additional explanations to avoid confusions. So here, Mascolet is giving you a lot of concepts together. So you have to make a stop and say, okay, let's understand what's going on here. So when you're studying markets, as I explained in the previous definition, the key idea is to endogenize wealth, okay? Remember that? Okay. In fact, in the guys at Chicago, right, the Chicago School of Econ, when they didn't want to be a standard, right, they used to separate micro and macro by the following names. They call micro price theory, right, and they call macro basically income theory or wealth theory, right? So essentially what they were saying is essentially when you study markets, so the macro object of study, as we're doing now, we're a little bit getting into the realm of macro, of course with micro foundations, but when you go into macro, essentially what you're trying to do is endogenize income. So trying to predict, how income is created, how income is distributed, right? That's the role of macro. And of course, prices can be thought more as a micro question if you want. But so what this is saying is, look, we're going to put the macro part, wait a little bit, but we're not going to deal with well effects. So we're going to do some mathematical tricks and, of course, some assumptions, economical assumptions that allow us to study the income effects of how endogenous income affects your consumption of corn. We're going to try to separate it. So we're going to assume that the consumption of corn as a part of your expenditure is so small that in fact, however changes your income doesn't really change the consumption of corn. So the only thing that's going to drive the consumption of corn is going to be the changes in prices. Now, flashback for you guys. When you draw the famous demand curve in your undergrad years, right? Wonderful years, right? So where was income? So you draw it, right? So who can right now visualize it? I can also use my iPad, right? But it's, and you have your price, you have your quantity, right? And where is income? It's not that. It's not there, right? It's simply not there. So that's usually called in your problem sets in undergrad, right? So it was the demand shifter, right? So if you have, for instance, an increase in income, then you shifted, to the north, and then of course, this was a shifter because it didn't appear in the graph. And that's essentially what we're doing mathematically. But now we're finally understanding why we want to do it. So essentially, what we're going to do it now, mathematically, is going to use the assumption of separability, right? The fact that we have this composite commodity containing everything else, that is more important as part of your budget share, right? So this, you can imagine, is 80% of the budget share, to say a number that is big, right? Doesn't need to be 80%, while corn is going to be less than 20, right? And this is a lot, right? Because I'm an ambient person, right? So with a lot of corn, so, it's not crazy for me. But, 20% is kind of big for corn. But in any case, my point, that's the only thing you need to understand, is that because in this analysis, we're assuming we have a good that is not a big part of your budget share, then essentially you can assume, without, loss of realism, that the changes in income are not really affecting the consumption of corn. The only thing that is really affecting the consumption of corn is changes in prices. And hence your famous, demand curve, where prices, increase, demand falls, right? And that's the only thing you need to know. So income is not there because income is assumed to not be affecting that. But the way to do it and the way to model it is through the assumption of separability. So the moment we have written this utility function, as you see here, where we have separated the numeraire, the rest of goods, from the consumption of corn, this additivity will make mathematically possible that when I derive the demand of corn, as we will do in a second, it will not depend on income, right? So it won't matter, right? And doing that, it will simplify a lot my competitive and market equilibrium analysis, because I will not have to deal with this complex object here in condition 2, where I have to endogenize the income and know the shares of your ownership of different firms, the profits that these firms make, and of course, how much you get from selling your endowment. All of this sounds really cool, but it's very hard to do in practice. So if you are hired, for instance, by a firm, you are hired by producers of corn, the corn producers in Ontario, and they want to know, how their demand changes with price changes, right? It will be very hard to do a general equilibrium analysis, right? Some people are very specialized in doing that. They get a lot of money for doing consultancy with general equilibrium. Most economists do partial equilibrium, where they assume essentially that income effects do not matter, and the only thing that are going to matter are prices. And this is justified by these two assumptions: separability, right? And the fact that the share of the corn inside the budget share is small enough such that it doesn't matter much as income changes, it doesn't change much your demand, okay? So that's the key assumption in this chapter, and this is called partial equilibrium analysis. Essentially, income effects are not important, right? You note, as any assumption, it may be realistic or useful in many situations, and in others, it is not realistic, right? So for instance, if you are studying the consumption of cars, right, luxury cars, you need to know income, right? There is no way to study it without income, right? If you want to study the classical example of partial equilibrium is the study cereal, right? So breakfast, ready-to-eat cereal. This is the classical thing that you say, look, originally, right, this ready-to-eat cereal, when it was assumed that it was the classical example of partial equilibrium, no income effects. It was in the times, of when Nivo was a student. So Nivo is the economist that studied cereal. So, and he did that, around the 90s. Right now, there is a lot of premium cereal, right? So maybe there is some income effects, but, who knows? When you become an IO economist, you will think about this topic again. So right now, we're going to think, you have in our example, the corn, and we'll keep going. Now, one important thing, as you realize, is that even, if we're just assuming that there is one good, there's still going to be capital J firms producing this single good. So each of these capital J firms produce good L, so corn, from this numeraire. So again, in this abstraction, in this model, remember that M is the composite good, right? It contains every other good that is not corn. So of course, in this very simple model, we just have one input, right? So given this single input, each of these capital J firms produce units of corn, okay? Everyone understands that? Now, to model the technology of these firms, given that it's so simple, one input and one output, we are not gonna need the full force of the production set. Instead, we're gonna use just the cost function. So remember, the cost function is the result of cost minimization, right? So given your production set and given a target output, you minimize costs, and the result of this minimization is going to be called the cost function. Now, one important thing. Remember that we can always normalize one price in these markets to one, because the only relative prices matter. In this market, we're going to normalize the price of the numeraire to one, okay? So everything is measuring money, right? The price of the numeraire is one. Given that, the price of the only input is one, right? So the cost, remember that per the video of the theory of the firm, is essentially a function of the target output, Q, and the price of the input, right? But since the price of the input is one, then the cost is just a function of the target output, right? Because the price of the input is fixed to one. So hence, The cost of each firm is just a function of the target output. Understood? Okay. So Cj, because each technology is different, of Qj, the quantity produced by firm of the corn. So Qj captures the quantity of corn produced by firm J. Okay, so essentially, right, this is the L production that is going to be assumed to be efficient. So this is already the result of cost minimization. And then the intermediate of M or good M demand of the firm J is given by Zj, right? So this is just to connect to the theory of the firm chapter. So remember that this gave everything in terms of the production set. So if I was to, basically I want to rewrite everything in terms of the production set chapter, then the production set will be capital J of capital Y of sub J is equal to the input minus Zj. The production is Qj, production of the output is positive. The inputs are going to be such that the cost is cost minimizing. The price of the numerator is 1, so it's 1 times a set J, and this is greater than or equal to the minimal cost, right? Because it's minimizing. So the cost function is twice continuous differentiable. So again, this is the analogous of the marginal utility. This is the marginal cost. As the quantity or target output increases, I have to pay more, right? So it's costlier. But interestingly here, as also how much costlier is getting, so the second derivative is also positive, right? So this is a convex technology, right? So decreasing returns, okay? Now we assume there is no initial endowment of good L. So in this economy, we start with no corn, right? And then essentially all corn is produced within the economy. And then consumers' initial endowment of the numerator, right? So the only thing that exists previously in the economy is omega of Mi. Remember that everything is price 1 of the intermediate goods, so essentially is measuring the same unit, so it's just money. And the total endowment is the summation of all endowment in the economy. Now, we are gonna rewrite the conditions of the Walrasian equilibrium within the assumptions that I just made. And we're gonna simplify a lot the 3 conditions and actually make it a computable, tractable model. So partial competitive equilibrium. Remember the key word here is partial, right? So we say that an allocation xq, so remember here the dimensions have changed. X is just corn, is a scalar. So here, this is just, you know, a stack of scalar values. So it's a big row vector, right? Of size capital I plus J, and then rows is just 1. So this is just characterizing the allocation of corn. So this is what each consumer from 1 to capital I consume of corn captured by X, and then all firms from 1 to capital J produce of corn, right? And then there is a single price of corn because the numerator is fixed to 1 that constitutes a partial competitive equilibrium, even only if 3 conditions are met. First, price. And right now, I'm just going to ask you to read it with equality because Mascolel again switched to inequality because a low coordinate solution, but you know, we can now think of it as equality, by the way. So in fact, I'm going to change it. I just following Mascolel, but it makes no sense. So price is equal to the marginal cost of producing Q. The marginal utility of X is equal to price. And this is true for all firms and for all consumers. And then the whole consumption for the whole collection of consumers is equal to the whole production of corn. So this is finally the mathematical description of the thing you did in undergrad, right? So what is this thing here? Who recognizes this? This is the famous supply curve, right? So the marginal cost is essentially describing the supply curve, right? What is this thing here? Is the marginal utility, right? Which is the demand curve, okay? And now you're saying you're describing an equilibrium, right? So you're saying essentially, look, if you equate equations 1 with equations 2, what happens? Supply means demand, right? That's what's happening, right? They're equated to P, which is a scalar, right? So essentially it means, right, that all of these things, which are curves, right, meet at a point, which is P. This is the equilibrium point, right? So this is the price that you find in the typical meeting of the supply and demand curve, right? And then finally, right, market clearing, everything that you consume is equal to everything that you produce. And why this is usually omitted from your graphical analysis in undergrad? Because you just have one consumer and one producer, right? So this is trivial, but when you have many consumers and many producers, then you have to keep track of all of them, right? So this essentially allows me to keep track of them. So this is equal everything that every consumer consumes, the summation of it is equal to the total production. What has been simplified here? First of all, right, is the same definition as before, because the first condition here essentially guarantees that the firms are profit maximizing. The second conditions here guarantee that consumers utility maximize. And the third condition here guarantees that market's clear. But things have been has been simplified greatly, right? Do you realize how much? First of all, right, there is no budget anymore, right? I'm not dealing with the endowment, right? I'm not dealing with the property or shares of the firms. I'm not dealing with profits, right? All of that has to do with endowment, right? So the tricks I'm now using is essentially that I can guarantee that if consumers preference maximize just by checking at this first order condition because of separability. So since the endowment enters with the plus M, maximizing with respect to this nonlinear term is enough to guarantee that the whole utility is maximized, okay, due to separability. This is the key property here, separability or what's called quasi-linearity, right? Because it's quasi-linear because M enters linearly and the phi is nonlinear, so hence the name quasi-linear. And then for firms, the same thing. We know that under the assumptions here, cost minimization is equal to profit maximization. So I just have to verify that the firms are cost minimizing. Because of the convex returns, I know that first order conditions are enough, right? And hence equating these first order conditions is equivalent to cost minimizing. The same here, right? For I forgot to say in the consumer problem that we assume crucially that phi was concave, right? Again, this means that first order conditions are sufficient for maximization because of concavity of phi, okay? Plus separability. And finally, right, I'm using here the lemma 8 that I presented before, saying that if I have all the assumptions met, here, of course, there is local association and so on. What is happening here is that instead of checking that all markets clear, here there are two markets, I can just check one market, and I can only check that market clears. So here, by checking that the corn market clears, I'm done. The market of the numeraire of the money good is also clearing. Okay. So now this is really wonderful. If you realize we have transformed this very complex thing that is very hard to compute and actually put it in a computer to a very simple thing that actually you can just compute, right? So I can take a cost function, I can take a marginal utility function, and then I can derive them, right? This is essentially the demand and supply analysis that people do. Find the meeting point, the price, and then just check that things clear up. So market clearing. So now there is another beauty about this result, right? This is telling you the role of prices as essentially equating marginal cost of different firms, marginal utility of different consumers, such that in the end, right, everything is able to get what they want by means of a single signal, the price. So price is this number that allows everyone, right, to be able to coordinate their different needs in a single point and be able to meet in the market, right, and be able to trade in a way that is beneficial to all of them. So essentially, if you realize the full force of this for the multiple consumers and multiple firms, there is a single price, not indexed by I or not indexed by J, a single number, right? That is able to coordinate heterogeneous marginal costs and heterogeneous marginal utilities, right? Into a single allocation, right? And this is very cool, right? This is very cool. And again, so one thing that I'm not doing on purpose is I'm not drawing again the supply and demand. Why? Because here we're not doing the supply and demand that you're doing in undergrad. Here we're doing a match black belt version. We have actually multiple consumers and multiple firms at the same time, right? So if I were to draw it, I would essentially drawing, 100 consumers, 1,000 firms, at the same time. And all of them meeting the same price. And then how do I draw even the market clearing, right? So the thing you have been drawing, in undergrad is essentially the case of one consumer, one firm, right? So here we're taking it, of course, to the very general framework. Is this generalization important? Yes, very. So one key progress that we have made as economists is even as apply guys, even when you become a consultant or fully apply guy, is recognizing the role of heterogeneity, right? So when you study in undergrad, the key leading assumption for all your exercises was that of the representative agent, right? So that somehow we could summarize all the behavior of consumers into a single agent, fictitious agent called the representative agent. This is something you have to read for the problem set, right? Very historical point. And the same thing with firms, that there is a representative firm. Now, in real life, we don't have a representative consumer nor a representative firm. In reality, we have individuals behaving in very different ways and very different firms producing in very different ways. And our analysis has to take into account this heterogeneity, right? So even if you study, for instance, the cereal market or the corn market, right? We want to learn the version with heterogeneity, right? Allowing for full heterogeneous preferences, okay? So that's an important extension. Now, so let's look for a second to the nasty part that we have avoided by using our nice assumptions. But you have to see it in order to connect it to the Walrasian equilibrium in its full generality. First of all, let's write what is the simplification, right? So remember that this MI is the term that enters linearly in the utility, right? So this is all the term that is not the corn. Now, by using the fact that this is locally associated, because the first derivatives of the utility are strictly positive, so essentially it's monotone, we can just use the structure of the budget constraint and essentially write that M is equal to the endowment. Remember, the price of the numerator is 1, so this is the budget constraint. So this will be price of the numerator times endowment, right? So the price of the numerator is 1, so this is just endowment, plus the shares of the profits of the firms. So what is the profit of the firm J? So it's P times the quantity of corn the firm produces minus the cost of producing that unit of corn, right? And then you multiply by the share, right? And then you sum over all shares you have of all firms. And then you subtract from this whatever you are paying for corn, right? So that is what you end up consuming of M, whatever you didn't pay in corn, whatever is of course of endowment, and whatever is coming from profits. So usually we don't study the consumption of the numerator because we already know that that market of the numerator is clear up so immediately by our lemma 8, and we are not interested in the consumption of other goods. But just to understand what's happening, right? Essentially, this is a hidden part, right? The things we left under the rug, okay? So this will be the consumption of the numerator M that essentially connects to the endogenous budget in the previous part. Nice thing about the partial equilibrium is we don't really need to do it. We're just doing it now to connect. But in our analysis, that's the part we're assuming enough separability and other assumptions such that we don't need to do this, right? And then the other thing you need to do for the full characterization of the equilibrium problem is also the the input demand of the firm, J. And in here, it's very simple because remember that the price of the good is equal, of the numerator is equal to 1. So the essentially whatever you consume for each target of Q is going to be equal to the demand of the input, right? Because this is a unitary price as well. And now we're just going to make a point that is actually going to become increasingly important. And I'm just going to ask you something simple. So imagine you have a description of a market such as this, when you have a collection of marginal utilities and a collection of marginal costs, okay? Okay, so we study the definition of the market. Now, when you have a model of different consumers, and essentially you're proposing an equilibrium condition, the first thing you should ask yourselves as good modelers is if, in fact, any price clearing the markets exists. So, said in another way, is there any partial equilibrium from this market? So some markets may fail to have an equilibrium, right? So when you're doing demand and supply analysis in undergrad, usually supply and demand meet, right? But that's a choice of the modeler, right? It's not guaranteed. So here we're going to provide minimal conditions such that this always happens. And the second thing you should ask is essentially when demand and supply meet, do they meet only one time? Or do they meet many times, right? So is it the equilibrium unique, right? Or is it multiple? And if it is multiple, can I say something about it, right? Can I control somehow the multiplicity, right? So these are the two classical questions in general equilibrium analysis. The first question is existence of an equilibrium, right? Existence of an equilibrium. And the second question is about uniqueness of the equilibrium, okay? And so these are important questions because if you're a modeler, the key thing that a model has to pass before prediction is internal consistency, right? If your model is not internal consistent, it means it's not logically sound. So lack of logical soundness may not sound bad for a sociologist, but for us, it's terrible, and for good reason, right? So if our models, do not, close, are not able to be internally consistent, they are not well defined. So they have, if you're writing code, they will have a bug. They will be wrong. So you need these objects to be correctly and internally consistent. So existence of a general equilibrium essentially is a sanity check that your model is well done. Okay, and then uniqueness, that's actually more scientific. So if you are making predictions and you want to predict prices, right? Then you would like to make a unique prediction of price, right? If you make multiple predictions of prices, then that's a little bit weird because then you have to select among equilibriums. That's a bit of a mess, right? Because how do you even know if, in reality, you are looking at one equilibrium or another? That creates a slippery slope. So if you predict wrong the price, you can say, oh, wait, but actually there is another price that, I have predicted, and you may be in another equilibrium, right? So that's, that's not very scientific, not very nice. But mathematically, we're gonna end up in the necessity of having multiple equilibrium just because our models can get very complex. So short story, right now we're in the easy version. So let's not get to the crazy part yet. We're gonna have a full chapter about existence and uniqueness. Right now we're in the simple, wonderful world of supply and demand a la undergrad. And here, the minimal conditions for existence is this. You take the maximum over all individuals, hence over I, of the first derivative of the marginal utility, evaluated at a consumption of 0 current. And then if this is greater than the minimum over all firms of the marginal of cost when you're producing 0, this in other words means that the demand curve is above the supply curves, right? So essentially because you have many demands and many supply curves, you are taking the max over demand curve. So it means that there exists one consumer, whose demand is above one supply curve, right? So essentially they will cross for those two consumers. And that turns out to be the necessary condition for the existence of an equilibrium here. So again, this is not very deep. We're going to have a full chapter on existence of general equilibrium. Right now, I'm just going to give you a historical anecdote. So have you heard of the famous Walras mistake? So Leon Walras, he's very famous because he invented, the culmination of the French economists, with the idea of general equilibrium. He gave us this great idea. But in doing so, he made a huge mistake. He was a good mathematician, but he was not a pure mathematician. He was an engineer. And, he formulated a system of equations describing the behavior of consumers and the behavior of firms. And then for the first time, his innovation was the market clearing condition. And then he said, look, if we have the following system of equations, having, for instance, L first order conditions for, J first order conditions for all firms, profit maximizing conditions, capital I first order conditions for all consumers, right? And then you have L market conditions for the market clearing because you have L markets. Then taken together, you have the I allocations for all consumers, J allocations for production plans, and then you have just counting, right? L market conditions that characterize the L prices. Hence, this is a square system that has the same number of equations as unknowns. I conclude that this system has a solution. Who can detect the Walras mistake? So he's claiming, right, that by the mere fact that you have the same number of equations as unknowns, then you are guaranteed to have a solution. I already told you it's a mistake. Now you have to tell me why this is a mistake. So this is not very hard. Just think of your classes of linear algebra. Who is a linear algebra ninja here?
Not all there is at least one equation that can be written as a linear combination of the others.
Okay, so that's great intuition, actually. So great, Martin. So Martin already detected, right? We have this condition saying that if we scale up everything and we have also one market that is redundant, right? So let's focus our point in the following way. So take a linear system of equations. So not even non-linear as this very complex stuff. Just take a simple linear system of equations. Have a matrix capital A times X equal to Y, right? X is the unknown, right? And then essentially you want to solve this problem, this equation, classical linear algebra problem. What is the necessary and sufficient condition for this system to have a solution? Is that this matrix of coefficients, right, the matrix A, is invertible, right? Another way to say that is invertible, because then you just multiply by the inverse, right? And then it will be X is equal to A to the inverse, right? The inverse of A, Y. And now, what are conditions under which invertibility fails? One of them is when you have deficiency of the rank of the equation, right? Of the matrix, right? So when one of the columns of this matrix is a linear combinations of the other. So you have a rank deficiency that basically fails the invertibility condition, and hence you don't have enough a solution. So essentially, what Martin says is correct. So you may have situations, even when you have the same number of equations as unknowns, that a system of equations, linear or nonlinear, may fail to have a solution. In fact, any system of equations can have no solution, one solution, or multiple solutions, right? So the three things can happen. So we need more assumptions in order to ensure that you have existence. Surprisingly, so who can Google when was Leon Walras alive? So Google it quickly, but he wasn't able to solve it. He did his famous mistake, and then economists were in the dark until the 60s. So Leon Walras, he was very early on. So did someone Google it? Yes, I would.
What his work must be like for 1870s, something like that.
1834. 910.
Yeah, thank
died
you.
in 1910.
Perfect. So imagine, so this was the 19th century. So we have to wait until the 20th century, and actually in the 60s, for the mathematicians getting bored with physics and moving to econ. So then we got Nash, we got Debreu, we have Arrow, we have Mackenzie. So it turns out that Mackenzie first, and then Arrow and Debreu were able to prove recently in the 60s that a very general model of exchange, a very general model of the Walrasian equilibrium had a solution. And we have a full chapter dedicated to that, together with a historical soap opera situation between Mackenzie and Arrow and Debreu. So we will have that soon. But right now, remember that Walras made a mistake. It was a big one. You have to make it the same mistake, right? So if you have a general system of equations, and in fact a competitive equilibrium, it is not guaranteed to have a solution, right? So a big part of our study in the second part of the class will be to be able to ensure the existence of an equilibrium. And existence of an equilibrium is a big deal because this allows internal consistency of our models, right? So we're going to actually spend a lot of time on that. Now, so after doing that, then you will be happy to apply this in macro, right? And then you always know your models are good, Okay, so we're done with this. Essentially, I'm gonna finish this full, notes on this chapter, but we're very close, and then we're gonna start with general equilibrium Thursday. Okay, so I'm gonna stop recording right now and take some questions as usual.